This is R.E. Sharma solution, class 12, chapter 9, continuity, MCQ, multiple choice question we are taking. If fx is these two functions are given and this is continuous at x equals 0, then a equals. Now here the point of contention or the continuity discontinuity is x equals 0. And if you go to left, the first function you are going to use. If you go to the right, the next function or the second function you are going to use. Okay. So we'll try to find out the LHL, RHL and try to find out the value of a. The first thing first is left hand limit. That is because x is 0, so we have to go on the left. So x will be 0 minus h. Right hand limit, we are going to take x as 0 plus h. So this a sine pi by 2 in place of x, replace it by negative h. So this is your explanation. If you want to do it by yourself, you can just have a look. Otherwise, you just follow me. So what do you get? It's minus h you have to put in place of x. So it is negative h plus 1. Negative h plus 1 can be written as 1 minus h. So I'm just writing 1 minus h here and multiplying pi by 2 with 1 minus h. We get pi by 2 minus pi by 2 h. So don't worry about pi by 2 minus h, just see pi by 2 minus something. So sine 90 minus theta is cos theta. It is a sine pi by 2 h. A cos sine 90 minus theta is cos theta. So you have this a cos pi by 2 h, right? So cos pi by 2 is, the h is 0, so cos 0 is 1. So a you get. On the right hand limit, you get 10x minus sin x by x cube. So 10h, I am replacing it by h, x by h, so 10h minus sin h divided by h cube it is. So this 10h can be written as sine by cos. Here you have sine. So numerator I am just taking. Sine I can take common. You get 1 minus cos divided by cos. That is 1 by cos minus 1 will be equivalent to 1 minus cos by cos. So sine into 1 minus cos by cos it is. Okay, sine by cos you can write it as tan. And 1 minus cos theta is 2 sine square theta by 2. So you can write 2 sine square. What is theta here? H. So 2 sine square h by 2. And you have this sine. And since we already have this cos in the denominator, so we have tan. Sine and cos is tan. So we have 2 sine square h by 2. What about the h cube in the denominator? It was already h cube. So we can utilize h square for sine square h by 2 and h below tan h. That is how we can utilize. But since it is sine square h by 2, you have to have h square by something. So h square by 4. So you have to multiply 4 here. Sine theta by theta limit theta tends to 0 is 1 and tan theta by theta limit theta tends to 0 is also 1. So both these you can just eliminate because they are just ones. So you have 2 and 4 remaining. 4 in the denominator, 2 in the numerator. So just cancel it out. It will be half. And you have to equate it with using the left hand limit. So a is equal to half. This is your answer. So if fx is continuous at x equals 0, a should be equal to 1 by 2. A option is the answer. First option is the answer. If fx are these three functions, one is a constant function which is 4, then the value of ab, for which ab is in pair, a comma b, for which fx cannot be continuous at x equals 1 is, please remember they are asking cannot be continuous. They are not asking can be continuous. So we have to select by rejecting. So these are the point. We have 0, 1 and 2 are the point. And since x equals 1 is the point given in 4 and we have to check for non-continuity at x equals 1. So we will go left, 1 minus h will go right, 1 plus h, left hand limit, right hand limit, x square plus b for the left hand limit, the second function for the right hand limit, and 4 is the value of the function at that value which is 1. I hope you got the idea. Let us take the left hand limit now. This is left hand limit. We have to put x as 1 minus h because the point of contention is 1 minus h. Right hand limit is x equals 1 plus h. Now just put 1 minus h in x square plus b. You have to put 1 plus h in x, this second function. Okay, so 1 minus h whole square plus b. Here you are, what are you going to write? 1 plus h plus 3 because it is x plus 3. So this is, you can just open it, and wherever h is there you can apply the limit and just remove those terms. So you have b plus 1 only. Okay, and this is a, please remember it is a into x square plus b. So we'll just include this a here. So a into 1, because we have to talk about a and b both. So a into x square plus b it is. So a 1 minus h whole square plus b, you can just cancel h square minus 2h, a plus b it is. On right hand side it is going to be 4 directly. So a plus b is equal to 4. That is what LHL equal to RHL equal to the value of the function at x equals to 1, which is 4. For which values this cannot be continuous? So when you add a and b, it should come as 4. It will be okay. Otherwise, it won't be okay. So 3 and 1 you add, it is 4. You add 4 and 0, it is going to be 4. You add 2 and 2, it is going to be 4. So all these are valid solutions. One of the solution phi 2 is not valid because 5 plus 2 is actually equal to 7, which is not equal to 4. So 5 plus 2 is 7. 7 is not equal to 4. So 5 and 2 is that point of not continuity, that is the a and b pair for which fk cannot be continuous at x equals 1. If the function fx is defined by fx is this, x not equal to 0, the first function, x equals to 0, the second function, which is k, constant function. So we'll take the left hand limit, right hand limit, and we'll try to equate. And since see, LHL RHL is not required because it is already being said that it is continuous at x equals to 0. So just find out the limit of x tends to 0 for the first function and equate it to k. So first function is log 1 plus 3x minus log 1 minus 2x, and you have to have a x in the denominator. Here also we have x in the denominator. So what do we need? So all this log 1 plus x divided by x and limit x tends to 0, or you can just write log 1 plus theta by theta, theta tends to 0, both are same, is equal to 1. When limit of that term is x or theta is tending to 1. So 3x we have included, so 3 has to be going up. 1 minus 2x, minus 2 in the denominator, minus 2 in the numerator. So just apply the limit. Log 1 plus 3x by 3x is 1. Log 1 minus 2x by minus 2x is 1. 3 remain here. Minus minus is plus, so 3 plus 2 is 5. Just equate it to k, and that k is going to be 5 for the continuity at x equals to 0. If fx is like this, the point is x equals 0, go left, you take the first function. When you go right, you use the third function. So 0 minus h on the left hand limit to 0 plus h on the right hand limit, then the value of a so that the function f may be continuous at x equals 0 is. Okay, let us find it out. Okay. And the most important trick of this question is you don't have to go for LHL and RHL. You will get, because there is only one value a, one variable you need to find out. So one equation is enough. If it would have been a and b, you need at least two functions, two equations. So LHL, RHL, you don't have to do RHL. Let us do it only on LHL, but you can do on RHL and equate it to the value of a. But I'm doing only on LHL. So x equals 0 minus h, that is minus h you have to put. So 1 minus cos 10 into minus h, cos minus theta is plus cos theta. So it will be only cos 10h divided by x square. X square minus h whole square is h square only. So 1 minus cos 10h divided by h square. 1 minus cos 10 theta is what? See, 1 minus cos theta is 2 sin square theta by 2 in every sense. So whatever theta is there, just divide it by 2. And 2 sin square, that is theta by 2. So 2 sin square 10h divided by 2 is 5h. So 2 sin square 5h it will be. and you have in the denominator you have h square, so you have to have a 5 square in the denominator because it is 5 sine 5h whole square. You already have h square, include 5 square, so sine 5h whole square, so you need to have a 5 in the denominator. That's what I'm talking about. So 5 h square is already there, 5 square you have included, so 5 square you have to go and put it in the numerator as well. So now just apply the limit here, sine theta by theta, limit theta tends to 0, so it is going to be 1. So what do you get? 2 into 5 square. This is going to be 1, which is sine 5h by 5h. Okay. Okay. So you get this as 1 and 2 into 5 square. So 5 square is 25. For 25 into 2 is 50. And since it is equal to the value of the function at a, value of the function at 0, which is equal to a. So RHL you don't have to find out. If you want, you can find out the RHL and equate it to a. That is the way you can do, but I am comfortable with the left hand side, so I found the answer as a equal to 50. So the option is second. The option you need to choose is the option number second. Okay. So this is how we are going to solve. We have been solving this type of question because we are on the 34th question. So all these questions are exactly like that. If fx is x sin x, x is not equal to 0, then the value of the function at x equals to 0, so that the function is continuous at x equals to 0 is. So you just have to find out the limit of x sin 1 by x. Limit x tends to 0 because x is not equal to 0. Fx is equal to f0. A is 0 here. f0. Okay. So let us see what we can get here. Now here is the next question is also giving you some certain thing I am going to explain there. But here we are not talking about sine 1 by x. We just need to talk about x tends to 0. Right? The whole idea of this exercise is finding out the limits. If you are comfortable with finding out the limits, this exercise will be very easy to you. Now when we apply the limit to x sine 1 by x, you just see limit x tends to 0 for x is 0. So whatever comes outside or with it in the multiplication, we don't worry about. Sine 1 by x, x is going to be 0 and 1 by 0 is infinite, sine infinite. So you can argue that sine and theta is always between -1 and 1. Whatever you put inside sine, it will be -1 and 1. But 1 by 0 is of course undescribable because sine infinity it is. But since 0 is multiplied by whatever it comes, 0 into infinity is also 0. So we can just say it is 0. The answer is 0. F0 is 0. You'll see what we are going to do in the next question. Now same discussion applies here. The value of k for which the function fx sine 1 by x for x not equal to 0, k for x equals to 0, continuous at x equal to 0 is. So we'll just find out the limit of sine 1 by x. We'll try to equate it with k. So sine 1 by x, limit of sine 1 by x is equal to k. But the problem here is that, as I told you, sine 1 by 0, anything in the denominator is not acceptable. Whether it is inside sine, whether it is outside sine, doesn't matter. So 0 into sine 1 by 0, the previous question we have just argued that 0 multiplied by anything is 0 only. So we'll go with 0. But here it is 1 by 0 in sine only. Sine infinity, you'll get an answer between -1 and 1. I'm not denying that. But inside 1 by 0 is not acceptable. So sine x tends to 0, sine 1 by x does not exist. Thus or consequently, there does not exist any k for fx that makes it as a continuous function. So none of these is the answer for this particular question, which was not in the previous question, remember. The values of the constant a, b, c for which the function fx is equal to this. So you have a constant for x equals to 0, b, and this may be continuous at x equals to 0. So there are point on the left of x equals 0. You have to take the first function. On the right, you have to take the last function. Okay. So a and b and c. So you need at least 3 equations in order to get. 3 variable, 3 equation, 2 variable, 2 equation, 1 variable, 1 equation. That is how it goes. So this left hand limit and right hand limit we have to equate, and we have to equate it with the value of the function at 0, which is actually b here. Which is b here. So just equate like that. Okay. So left hand limit, let us start with the left hand limit. This has to be applied on 1 plus ax to the power 1 by x. And since it is 0, we have left hand limit as 0 minus h. So we have to replace x by minus negative h basically. So those who wants to do by themselves, I'm just showing you the result, how you are going to write it. We'll talk about the first one and we'll go subsequently to the second part of the right hand limit. But left hand limit is, I'm replacing the x by negative h. So this is negative h, 1 minus ah, and to the power 1 by x, just replace it by negative h. So 1 minus ah to the power 1 by 1 minus h, or minus 1 by h. So this is equivalent to what? F0, which is b. Here it is b. So b is equal to 1 minus ah to the power 1 by minus 1 by h. So basically it is 1 minus ah, b equals 1 minus ah to the power minus 1 by h. Whenever you have a power like this, you just take log. It will be very easy. So when you take the log b, the power comes outside, minus 1 by h, and then you have log 1 minus ah. So log, and please remember this log is log base e. The base is e. So now you have to have a negative ah in the denominator. The negative ah we have to put in the numerator. Since already a negative h is there, because log 1 plus x by x is 1, limit x tends to 0. But we have a negative 1 by h in the numerator, in the front already, which has come in front because we have taken the log. So what you have to do is, this negative h was already there. This was already there, minus h. So you just have to introduce an a in the numerator and in the denominator. Log 1 plus x by x, as I just told you, is going to be equal to 1. So when you apply the limit goes inside the log, and this is going to be simply 1. Log of this is going to be 1, and only a will remain. So log b equals a. So this is the first relation, e raised to the power a is b. This is the first relation. We are going to just keep it so that we go to the second part and then see what comes, and then we'll reuse this log b equals a whenever it is required, because we are intending to find out the value of a, b and c. Okay, so let us come to the second part of the right hand limit basically. This, just keep in mind, I'm just replacing all of it. We'll use it in a short while. Now x plus c to the power, this is x plus c to the power 1 by 3, and denominator you have x plus 1 to the power 1 by 2. So replace x by 0 plus h, that is h, in place of x wherever it is. So h plus c to the power 1 by 3 minus 1, and then you have h plus 1 to the power 1 by 2 minus 1. Now there is a typo error or whatever it is. See, always remember x raised to the power n minus a to the power n divided by x minus a, limit x tends to a, this n comes in front, a to the power n minus 1. This is the result of the limit. So we will try to make these terms in numerator and denominator in such a way so that we get the limit x tends to a, and we can finally find out and replace it by a raised to the power n minus 1. In the denominator you say that this is h plus 1 or h plus c to the power 1 by 2. This is root only, and whenever there is a root you go for rationalization. Okay, so half power is root only. So h plus 1 to the power half plus 1, h plus 1 to the power half plus 1, we are multiplying numerator denominator in order to rationalize the denominator of this term. So h plus c to the power 1 by 3 minus 1, and this is going to be h plus 1 to the power half plus 1. Now this is going to be a square minus b square, so h plus 1 half to the square minus 1 square. 2 gets cancelled, h plus 1 minus 1, 1 gets cancelled, you get only h. You just have h. So you have h in the denominator. Now you can here only apply the limit on the term which we got in the numerator. H plus 1 to the power half plus 1. So this is going to be 1 plus h is 0, 1 plus 1 to the power half, that is 1 plus 1, that is 2. But we'll deal with it later. We are discussing the x raised n minus a raised n by x minus a. So you have h plus c minus 1. I am saying we have to have h plus c minus 1 in the denominator also. When we have h plus c minus 1 in the denominator, and since in the answers we see c equals 1, this is a point you have to understand really well. See, h was already there, h is already there. We have to include certain thing and subtract something so that it becomes h plus c minus 1. So apply the limit h tends to 0 on the right, which I was saying 1 root is 1 only, 1 plus 1 is 2. So 1 plus 1 is 2, this will be using later. But here h plus c to the power 1 by 3 minus 1 by 3. So in order to make it as x raised n minus a raised n by x minus a, we need x minus a in the denominator. So h plus c minus 1 we need. But since in the options of the answer c is equal to 1, see here. So we have a c equals 1 here. So if h plus c minus 1, so I am talking about c equals 1 here. So you can write the denominator as h plus 1 minus 1, or essentially it can be h plus c minus 1, just to make it similar to the numerator. C equals 1 is already the option, so we can always employ it. So c both are h plus c minus c. We are saying h plus c minus c because c gets cancelled, you get h. But here 1c I am writing c, 1c I am writing it as 1 because it is in the answer. So once you have h plus c minus 1 in the denominator, it follows the form or takes the form of this x raised n minus a raised n by x minus a. Okay. So this is going to be n a raised to the power n minus 1, 1 by 3, 1 to the power, that is c is basically here. 1 to the power 1 by 3 minus 1. 1 by 3 minus 1 is minus 2 by 3. Now 1 to the power anything is going to be 1 only. It doesn't matter. C is 1 we are taking here. In the answers options it is already given. So we can either use C as 1 or use C equals minus 1 and then try to solve it. But since C that is 1 to the power minus 2 by 3 or whatever it is, 1 to the power anything is 1 only. So this is basically 2 was on the right, 1 by 3 is there, and this is equal to what? 2 is already there. So this is equal to what? Left hand limit, right hand limit. Remember, I told you it is equal to b. The value of the function at x equal to 0. So b is equal to 2 by 3. So basically b is equal to 2 by 3. So from the right hand limit you got b as 2 by 3. And you remember a was equal to log b? The first left hand limit when I was showing you, we came up with the solution that a equals log b. So a is equal to log, replace b by 2 by 3, a equals log 2 by 3. We have taken c equals 1. So a and b is matching. A is log 2 by 3, b is 2 by 3. So this is the answer. Okay. Okay, this we are going to take in the next discussion. Till then, thank you so much and take care of yourself.